Hi everyone, this is Bashi Ferdousi, and as Anne said, I'm FDL alumni. I was FDL researcher back in 2020 and then came back at 2023. I think when I remember at one time, James Parr told us once you become FDLer, you will always be FDLer. So yeah, that's a proof of concept. So yeah, I like it's a great community, and then once you join, we never let you leave. So if you could go to next slide, please. So I'm going to talk about a little bit about our research. So our research starts because we want to see the interaction between the sun and Earth. So sun is it throws these massive coronal mass ejections and high energetic particles all the time to the Earth's magnetosphere. And our Earth magnetosphere, as you can see, is supposed to help, it's supposed to protect us from all these harms. But like any system in the universe, is not perfect. So these particles penetrate to our system. So next slide, please. So most of the time, this interaction shows itself as beautiful auroras. And you see it in northern poles and southern poles. But if you could go to the next slide, this is not always true. So these interactions sometimes leads to large blackouts. The blackouts I'm talking is not like, you lose your power for a couple of hours or even days. It's just like a whole regional blackouts that like in order to we come back to life, it takes months. And so we wanted to see if, and then I will show you what the next slide, please. So these events, like Carrington events at 1859 happened. So when I'm talking about large blackouts, I will describe what it means. So as you could see, the auroras were displayed as low as Boston areas, and then even there's there are documents that is very low latitude. Also, the only technology that we had back then was telegraph. So the telegraphs went on fire, and then people were unplugging them, but they could still communicate because there was so much current in the ionosphere. So next slide. So people sometimes argue these events are rare, it's not happening, but to be honest, we're overdue. So this event, Stereo A saw this event in 2012. So it was the same magnitude, but it went we missed it by a couple of days. If it has been happened, it would have been devastating. So because nowadays we are dependent on technologies, and there are a couple of individual studies, they're independent. So that they say these events happen every 3 or 4 solar cycles or every 60 to 100 years. So we are much overdue. Next slide, please. So the question is, can we prepare for such geomagnetic storms? Next slide. So, in order to do these, forecast these geomagnetic storms, the stakeholders their model needs to be fast, localized, and actionable. Because there are so many MHD models, numerical physics-based models that are doing these forecasting, but they're computationally expensive. So that's why we need to have machine learning model to do this forecasting. Also, as you could see on the right side, these events are very localized. So we have to have high resolution. And also we need sufficient lead time. So we should be able to give couple of days lead time if possible, and then with uncertainties associated with it. Like, for example, you see something during the weather, with the rain, we say it's going to rain probably 50% tomorrow. So we need to have some uncertainties associated with it. Next slide, please. So our research is sun to mud forecasting. So basically, we look at the images of the sun from the SDO, and then we are able to predict magnetic field perturbation, which is a proxy for geomagnetic induced currents around the Earth. Next slide, please. So this is how our model works. On the sun side, we take the images of the sun, and then we use coronal hole and active regions, and we're able to predict the solar wind parameters at L1 point, the location between the sun and Earth that satellites are usually measure things. We're able to provide those solar wind parameters at L1 point, and then after that, we have a Dagger model, which started in 2020, and we use spherical harmonics, and we use machine learning, GRUs, to predict spherical harmonic coefficients globally on the Earth. So that's how we do the prediction. Next slide, please. So this is our model. On the left, you can see, on the bottom, you could see how we get it from the sun. This is one of our prediction and the target for the DBN, or magnetic field perturbation. And on the right, you could see how can we globally predict these things. And then we compared with the ground truth. We have super measurements, but they are very sparse. They're not like, all over the place. They're like different with thousands of kilometers. And so that's why it's important. We predict this magnetic field perturbation like all over in the Northern Hemisphere. Next slide, please. So this is our team. So this is the 2020 team, including me, Theo, Panos, and Vishal as researchers. And then we had great faculties. And then what we did, after our project ended, we just continued working on it. And then in 2022, Vishal published a paper about our model. In 2023, next slide, please. Yes, we had a new team to come over, and then we finished the whole chain, sun to mud. So we have we had Raman and Sahiti and Mike, and then we were able to get the model to the next level. That's what I was saying. If you become FDLR, you would always stick around. It's a great community. You see these fun pictures. We're always having fun. These 8 weeks would be your ordinary 8 weeks. You're gonna remember these 8 weeks if you join us. Thank you.